So I'll just I would like you to make use of the chat box so that you can actually introduce yourself. So I can get to know you. So how do you actually introduce yourself? Just tell me your name and you're currently working, your occupation at the moment. And if you're a student, you can just drop if you're a student also too. And likewise also too, you can just tell us why you're joining this bootcamp also too. So let me just why you do that, why I with you why you do that. It's very, very important. Just make use of the chat box. Can see your name, or sometimes some people log in on a phone. I can see Alfred David. So they just tell us your patients and why you are joining this bootcamp. So the same thing as okay. So I want you to do the same thing likewise also too. So I believe you can all hear me. So can you all hear me? Can you all hear me? So if you're in the place in an environment that is quite noisy, you can just use the chat box to confirm if you can hear me also too. I would like to appreciate the fact that my students are right here in the meeting. So I'd like to confirm if you are right here in the meeting by dropping a chat on the chat box. So let me tell you about myself. My name is Tobida Shaolu. I'm a data scientist and I currently work with a company in the US as a data scientist. Data science has been an interesting field, a very amazing field, and a great one to actually get into. So strongly believe you coming to this bootcamp is going to change your knowledge, it's going to change your idea about what data science is. People see it as a very, very complex and difficult field to actually venture into, which is actually not true. It's not true. It's very, very easy field to actually venture into and quite easy because we have tools that basically solve all of these things for us easily. So I'm waiting for us to drop our name in the chat box and our occupation. Yes. Olutosin, can you hear me? I need to respond. Olutosin, can you hear me?
Yes, I can hear you, sir.
Okay, thank you so much for the response. Okay, can you hear me?
Yes, I can hear you.
Okay, perfect then. Olatunji, can you hear me?
Yes, I can hear you.
Okay, thank you so much. Yeah, I just need to get your attention before we dive into today's activities. So I know it may be the first time for some of us, and it may not be for some of us hearing the word data science. So you can just tell me what knowledge you have about data science. What knowledge do you have about data science? Yes. You can make use of the chat box if you are in an environment that is quite noisy. And if you want to talk, you can just unmute yourself and talk also too. Don't be shy, just feel free. This is just like a chat for us. It's not something it's not like we're writing an exam here. So just feel free, just relate. Let's just relate with one another. So why data science? So what do we understand by the word data science? Yes, I think it's right time I call name. Someone is saying, don't call me. Solving real problem using data. Wonderful. That's so amazing. Like, I really love that. That just caught the attention of today's activities. So you solving real world data, making use of what? You solving real world problem, making use of data. That's really, really amazing. Thanks so much for that definition, Mr. Olatunji. Yes. Who else is coming on? Yes. Let's make it interactive, please. Let's make it interactive, please. Yes. So, David, can you help us out with it? Can you help us out with it, David? Can confirm if David can. Okay. Olutosin, can you help me? Can you help us
Yes,
out?
sir, I can hear you, but I'm on transit.
Okay. I get that. I get that. You can just make use of the chat box then. So you can make use of the chat box before we dive in today's bootcamp. So our bootcamp is going to be holding today, tomorrow, same time, and same Zoom link also too. As you all know, this bootcamp is actually organized by Amdor Analytics. So we are actually organizing this bootcamp to expose you to a field called data science. Some of us are enthusiastic about this field. Sorry, I'm new to it, but I call it a scientific method of dealing with data. Wonderful. That's really, really amazing. So yeah, you're really right. You're right. The scientific method of dealing with data, yes. So we learning about that scientific method of actually dealing with data. So that's what actually brings rise to data science. So these science come about as a result of we solving problem, making use of data. So, and there's need for we to follow some scientific method in solving basic human problems. So that's what give rise to data science. So I'll be sharing my screen. So I'll be sharing my screen right away. So we have this data science bootcamp. So we have, so what is actually what data science? We said is solving problem with data, just like the definition you've all given in the chat box. Is we solving problem, making use of what? Data. That is what is basically what data what science. It sounds cool, right? So that's what actually makes once you actually solve problem, making use of data, you term it as data science. So there are some scientific methods. Someone says scientific method that we actually have to follow. So this scientific method is what are the techniques that we use in solving a problem, making use of what? Data. So we said problem could be scientific, it could be social, it could be a business what problem also too. So depending on the problem we are basically trying to solve. So we are basically saying that we have data what? Problem. So we have data problem. So once we are able to identify the problem we are solving, then we need to collect data and understand that data. There's need for we to collect data and understand the data. But one thing we always realize in the real world is that most data collected are not clean. No, not even most. All data we collect in the real world in solving basic problems that we want to solve, making use of data are not clean. So they are not basically clean. I will tell you that refer. So problem, the data we collect to solve real world problems are basically not clean. So it's our work as a data scientist to actually clean and format that data in the right manners for users. So we use that data to create what? Solutions. So we use that data to create solutions. So I've come in contact with many students and saying that, oh, what make a good what? Data scientist. So when you say you're a data scientist, what make you to become a good data scientist? Quite nothing much. So you need to have a background in math and statistics. Someone said, man, I run from statistics and mathematics right there in school. Am I going to face this again in my career? Oh, yeah. But not the so-called mathematics and statistics you do back then, making use of hand to solve all of those things. We have software that have been built with just a single line. You can solve all of these basic problems you solved back then, making use of 3A4, 5A4, you understand? So we are saying that we have tools that we make use of as a data scientist in solving these problems. So another thing that could make you become a good scientist and expertise, you need to have a domain knowledge in a particular field. There's need for you to have, it could be someone that works in a supermarket. It can be someone that works in the banking sector. It can be someone that works in the manufacturing industries. So there's need for you to have an expertise, not really much expertise, but we call it as a form of what? Domain knowledge. There's need for you to have a domain knowledge. So after you gaining this domain knowledge about a particular sector you actually work, or based on the passion for a particular field you draw interest on. So after you gain domain knowledge in that particular field, then you want to what? Identify how you can use your hacking skills, bringing in together your programming skills you've learned, making use of Python to solve that real world problem in a scientific method. That is what we basically know to become someone that is called a visual scientist. So it's a very, very interesting field. It's a very, very good field. You may feel like, oh, math and stats, I'm not really good at math and stats. I don't have good knowledge in math and stats. Can I venture into this field? Yes, you can. Just like I said, we have software that have been developed that can help us in computation of mathematics and statistics. And when you're trying to look at mathematics and statistics that we're virtually doing in this field, they are quite simple, not difficult. And these are being done making use of what? Of our tools that we use in solving our problem. So proceeding from there. So we said we use our data to actually create what? Solutions in basically two ways. In basically what? Two ways, and in sometimes in both ways. So in both ways. So we have the data analysis aspect and we have the machine learning aspect also too. Or you can actually venture as a data scientist, you are going to be making use of both data analysis and machine learning method in solving problems. So that's one thing we do being a data scientist. That's one of the advantages we have over data analysis. So you see this aspect, the data analysis aspect and the machine learning aspect. I hope I'm not too fast. Please, let's make use of the chat box. I really love to see my students make use of the chat box. So let's make use of the chat box. If you are having any difficulty or any question, kindly make use of the chat box. So we being a data scientist, we have the skill set of being a data analyst and at the same time having background in what? Machine learning also too. So I can see some are actually joining us. Thank you so much for joining these sections. So we are basically saying that, okay, we have a chat following through. Thank you so much, Abu Rashid. Thank you. So people say these things are very, very challenging. They are quite simple and very straightforward. Amdor Analytics, we have curriculum that has been designed to ensure that you don't have any background in mathematics, in statistics, in programming, in data analysis. We have a curriculum that has been designed to ensure that all of these things are being covered so that by the end of your training with us, you gain good foundation, good knowledge, making use of what this data analysis tools in solving problems. And this is one of the top field at the moment right now. This is one of the interesting field, top field, high-paying field at the moment right now. So let's look at data analysis. Like I said, as a data science person, you are a combination of being a data analyst and having a background in machine learning also too. So let's look at who a data analysis. So what is data analysis? So why data analysis? So what is actually what data analysis? You said data analysis is using data to discover useful information. So you want to check from your data, okay, you have a collection of data for a particular store. You want to check the months you have the highest sales, the months you have the lowest sales, the months you have the highest customers, the months you have a particular sales item. These are work of data analysis. These are work of data analysis. And you guys can see, we said data is anything you can measure or you can what? Record. That's what we basically called what? Data. It's tend to be anything that you can actually measure or you can actually what? Record. I will call statistics. We call statistics. Like we're summarizing and visualizing make characteristics of data. Just like I said, probably making use of a pie chart to represent the population of male or female in a particular country, in a particular state. These are what it tends to be, what we call what? The application of what? Statistics in what? Data analysis. So we have algorithm. So we said algorithm, what we call the applying of algorithm to find patterns in data. That's what we do as a data scientist. We actually apply different algorithms to understand the patterns in what? In data. So that's what we do being a data scientist. Let's proceed. So what is actually machine learning? So we said, like we said, data is anything you can actually measure or you can actually what? Record. And being a data analyst, you deal with algorithms. You deal with different algorithms. Even though being a data analyst, you're not going to be going deep into those algorithms. Being a data analyst, you want to focus on just a simple part of the algorithms. But in terms of data science, we are trying to focus on the simple algorithm and looking at the more sophisticated one to solve our problem, because we strongly believe that problems are not being solved making use of the same pattern. This is of the same pattern. It's the way you solve a particular problem is not the same way you're going to solve another problem, and the subsequent one also too. So we said problems are dynamic. Now I say problems are dynamic, just like we have in Nigeria right now. Fuel prices are changing. You can't say because you buy fuel 130 back then in probably 2012 or something, then you want to buy fuel right now at 130. No, it's dynamic. So the problem the way you solve that problem at that particular time is different from the way you're going to solve the problem at this moment, because there have been changes in terms of time. So we as a data scientist, what we do, we build models. We involve ourselves in building models. Excuse me. So we involve ourselves in building what? Models. So we said models simply means relationship between different what? Variables. Our relationship between different what? Variables. So sometimes when we are trying to, for instance, when you are trying to make some food, probably you are trying to make jollof rice, you have some variables actually. You may not just know that. You have some variables, you have your salt, you have your onions, you have your pepper, you have your rice, you have your water, everything. You mix everything together. Then you taste it, you say, oh, this food is very sweet. Then you have your Maggi, your seasoning also too. So you say this food is very sweet. Then next time when you are trying to cook, you want to try to make use of the same measure you use in preparing the first one, so that you could have the same result you earlier have while you make your first meal. So these are models. These are relationships. So you relate all those things, you mix all those things together to create something meaningful, which is your food, your jollof rice, probably. So one thing we also do being a data scientist person is evaluation. We want to evaluate how well does this model work. Just like your food, for instance, don't forget your variables are your seasoning, your salt, your Maggi, your granite oil, all these things you make use of. These are your variables that you actually make use of. So the thing you want to look at is how does this model work? So you taste your food and say, oh, this food look good. So next time when you're trying to cook, you already have that kind of mindset of the measure. Okay, I need to put just 2 Maggi, then it's going to taste good. I need to measure my rice. Maybe it's going to be half derica, 2 cups of rice, and it's going to look good, but I mix everything up. So these are things we basically do also too, being a little what? Scientist. So don't forget, data science is actually coming from 2 words, data and science. So just like we have in our group chat from Olatunji says solving real world problem using data. So we said data is actually anything you can measure or you can record. So data is anything you can measure, you can record. And we have from David, he said is like using scientific method of dealing with data. So they actually give a perfect definition of data science field. So data and science, so data is just there as a measure or record that you have there. And science is application of scientific method in solving problem, data problem, solving problem, making use of what? Data. So that's basically the aspect of what data science. So, and at Amdor Analytics, we basically have a curriculum well structured, well designed to take you from just you having no knowledge about the field of data science into someone that become an expert. Wow, it's so amazing. Like the curriculum has just been designed to ensure that you become an expert in that particular field. So let's proceed. So we said is about we being a data scientist is about we creating models. Is we creating models. You feel like, what is this model? What do you mean by model? So every reward problem has a model. Every reward problem has a model. So we have a model that is being designed for we predicting the price of fuel for the next year. We have a model. Can have a model that has been designed to predict the house price. That's a model. Can have a model to cluster your customer into high purchasing customer, low purchasing customer, neutral purchasing customer. These are models. So we're creating and using this model that will learn from data. So that's what we basically do. We basically get ourselves involved in theory aspect, the regression, the classification, and the clustering aspect. So we are going to be looking at this part. So means we coming up with prediction, extract knowledge and insight from that particular data. That's what we basically do. Being a data scientist. So in a data scientist, what we basically do is to build models. We build models. And this model we build is not like the particular model you build for a problem, the same model you're going to build for the other problem. Just like I said, most problems are dynamic. So we actually build different models to actually solve different problems. You can't use the same model used for predicting price for the same model. You can't use that same model to predict house price. No, they are different things entirely. So that means there's need for we to understand that we need to know how to build models to solve problems. So what we basically do is to solve problem, making use of data. So based on this problem that we encounter, they are basically divided into three parts. The problem we actually encounter are actually divided into three parts. We are going to be looking at those three parts in today's class. I will look at a sample of it we'll look at a project on one of them in our class tomorrow. So I want us to have understanding of this, that most problems we face are dynamic. They are dynamic. You can't use the same model to solve different problems. You have to build different model to solve what? The problems. Yes, I have a chart. Yeah, so we have our attendance that's actually going on also too. So you can use the Google form there to mark your attendance so that you can have access to the recording that we have after the class. So the traditional way of using machine learning back then to when we have sophisticated tools like we have right now is we just have the data, we have the program being generated, and we send it out, then we have our output. But at this time, we have our data being sent out, then we have our output also too. We have our data being sent out, then we have our program also too. Then we are going to have our output. We are going to look at how this actually works. So we are going to look at how this actually works. So we said the basic examples of applications of job opportunities that data science do is an example. We have identification of zip code from handwritten digits. So probably you have thousands of zip code written in books, and they were like, okay, you know what? This zip code is written in books. We want to take this zip code to an Excel sheet. So how do we solve it? Imagine you have like 10,000 of this zip code written in book. Then you want to translate it from being and book stuff into an Excel sheet. So it's very time consuming. But right now, we have programs that can actually do that for us. With just 2 to 5 lines of code, you've done that. You have that being solved. You have that being solved. That's just like a way we can actually solve problems, making use of the tools that we have been able with scientists. So we have another example is detecting community in social network. We want to look at the kind of network that is present in a particular social environment. So these are what we do. Probably you have this map, and you want to check area with dense population, large population, the kind of population you have in a particular environment. These are things that are being done making use of what? Of the knowledge you're going to gain from our class. When you join our class, about how you can solve this problem. We have so many of these problems. Example also too, you may probably find this in Uber or InDrive or your boat. When you try to make use of your boat, it's predicting the traffic volume at rush hour. Like you want to predict that, okay, the boat will say turn right, turn left. There's already a model that is predicting that, okay, we pass this side, there's a traffic going on, it's going to take you this so much of time. Why don't you take this route? Suggesting routes, all of those kind of things are things that are being done, making use of what? The knowledge of data science. We have another example, is detecting fraudulent credit card transactions. So these are things that is also being done, making use of what? Data science. We want to check if a credit card have expired. So these are things that are being done, make use of data science, because you already have the data available just for you to build the model. Once you have the model being built, then you want to check that, okay, this model has been built, then you can use it to what? To determine if a particular action is fraudulent or not fraudulent. So it's determine the location of distribution center based on customer or resident. Probably you have a large database, you own a supermarket, then you can use that knowledge of data science to determine the geographical area. Okay, I have this customer that does come from this particular region most. I think if I'm able to build a supermarket in that region, they can actually be making their purchase in that area, and I can actually attract more customers also too in that region, because my customer can also say, oh, this program, this supermarket is already available in this particular place. Well, you know, these are things that are being done, making use of what? What? Data science. These are things that are being done, making use of data science. So we have types of machine learning problems. We have types of machine learning problems. We have type of problems that are being faced in the real world. So we have types of machine learning problem. So say a machine can learn to solve a problem by following one of these following, by following any of the following three approaches. These are the ways in which a machine can learn. We have one, the supervised learning, we have the unsupervised learning, and we have the reinforcement learning. These are the three major problems in which we data scientists work in: the supervised learning, unsupervised learning, and reinforcement learning. So these are the basic three problems that we basically work in being in data science. So these are three basic problems we need to understand. When we said we're a data scientist, when a problem, we look at a particular problem and say, oh, this problem is a supervised learning problem. This problem is an unsupervised learning problem. This problem is a reinforcement learning problem. Yes, I hope I'm not too fast. I hope you are all following. Don't forget to fill the attendance so that you can have access to the recording immediately after the class. So I need a response. Kindly drop your response on the chat box. I hope you're following me in this class, not like you are just in this class. Yes, I need the response. Please just let's make use of the chat box. We are in an environment that is very noisy. So let's make use of the chat box. Yes. Okay, thank you so much, Abdul Rashid. Thank you so much, Mohammed. Thank you so much. So we have this three basic problem. So I can tell you all real world problems are just this basic three problems that we identify so far for now. They are just these basic three problems. We have the supervised learning, unsupervised learning, and reinforcement learning. And I will tell you the truth. These are things you are very, very familiar with. So these are things you are very, very familiar with. So let's look at supervised learning. So what do we mean by the word supervised learning? So what do we mean by the word supervised? So what do we mean by the word supervised? So I need a response from us. I know we are not new to the word supervised. So what do we mean by the word supervised? Yes, I don't want to call name. Let's just make use of the chat box. What do we mean by the word supervised? People feel like, I know this word. What do we mean by the word supervised? Following, sir. Okay, someone just left. Yes. Checking or inspecting, confirmed. That's very, very right. Checking or inspecting. Yes, I need more response. What do we mean by the word supervised? So what do we mean by the word supervised? Yes. I need a response. I will call name. Okay. What do you mean by the word supervised? Sunday. What do you mean by the word supervised? Yes. What do you mean by the word supervised? I need a response. I need a response, please. Let's make this interactive. Let's make this interactive. What do we mean by the word supervised? Sunday. I don't think, are you on this call? Sunday, are you on this call? Are you with us? To monitor, yes. To monitor performance. Yes, that's very, very correct. I love that. I love that. I love that. That's good. That's impressive. So these are the basic three problems we have: supervised learning. So let's look at what supervised learning. Yes. Guiding someone in carrying out their tasks by a superior officer or contemporary in an organization for the benefit of corporate growth. Yes, that is really, really amazing. That is really amazing. So that is amazing. So these are the three basic problems we solve. These are the three basic problems we are going to train you on how to identify them, how to solve them. And you really, really feel excited when you get all of this knowledge. Because one thing I love doing is solving problems. I love solving problems. That's one thing that we do. To my layman, my supervising me might be interpreted as not automated or unmanned. Ah, man, this English is just too much. Yes, is as not automated but manned. Yeah, that's perfect. That's perfect. I love that. So let's look at unsupervised. Let's look at supervised learning. So what do we tend to be called supervised learning? To say this is a learning technique in which we teach or train machine using data which is well labeled. So it's we training machine or building model. Let me put it that way: building model using data which is well labeled. The big question you could ask me is what's the meaning of well label? What's the meaning of label? So let's see what it means. So to understand supervised learning, let's consider an analogy. As kids, we all needed guidance to solve math problem, right? Oh, this is 2 plus 2 is 4, 3 times 3, 9. These are guidance from our teacher. So our teacher helps us understand what addition is, how it is being done. Similarly, you can think of supervised learning as a type of machine learning that involves a guide. There is a pattern. There is something that we're actually following. The label data set is a teacher that will train you to understand the patterns in the what? In the data. The data set is nothing but the training what? Data set. So what are we trying to say? When we are looking at supervised learning in such a way that there's something we call dependent variables and independent variables. There's something we call, something I was trying to explain something to us earlier. When you are trying to make food, you use different variables, different ingredients. The likes of, what do you call it? The likes of your seasoning, your Maggi, your salt. These are ingredients. These are variables. These are variables. So when you mix all of these variables together, what you are trying to get an outcome, probably you want to prepare a jollof rice. So you put all of these variables together. You want to prepare a jollof rice. You need your rice. You need a granola. You need your seasoning. You need your Maggi. You need all of those. Those things are your independent variables. So by the time it's not ready, you have your dependent variables called the rice. Example. For we to determine the price of a house, for we to determine the price of a house, there are some things you want to consider. Like if you say, this house is 3 million naira annual rent, and they tell you the house is just mini flat, and you feel like, oh, okay. And where is this house located? It's in Oshogbo, and it's 1 million naira per 3 million naira per year. And you feel like, no, it can't be. If house in Lagos is 3 million naira per year and it's mini flat, we can still accept that based on the location. But at Oshogbo, you get a mini flat of 3 million naira per year, then then I don't think that is actually possible. So what we are trying to say is that we have some factors that will determine the price of a particular thing. So we saw something dependent variables and we call something independent variables. So independent variables are factors that are responsible for our dependent variables. These are factors that are responsible for our dependent variables. So in supervised learning, what we are trying to say is that we have dependent variables and we have our independent variables in our supervised learning. So our independent variables are what we use to predict our dependent variables. So it's we building a model with our independent variable to get a particular dependent variable. So let's look at it as an example. So let me stop sharing this screen and show. Okay, let's look at this. I think this is going to help us out. So we said we have some label data. These are label data. This is like a data. We have the label data. And our data is able to identify, okay, this person is Tom, this person is Jerry, By the time you do the data, you do the cleaning, you carry out the exploratory data analysis. That is the meaning of EDA. Then you choose the algorithm you want to use to build your model. Choose the algorithm you want to use to build it. So what we do at Amdor Analytics is that we teach you those algorithms you're going to be using to build models to solve your problems. So after you build your model, make use a particular algorithm, you want to check the model evaluation. Is this model very, very okay? Is it good for the problem I'm trying to solve? Is it solving the problem I'm trying to work with? So once you build a model, then you have a label output. Then you have this, oh, when you see this particular person, you come here, look at this, you say, oh, this is Jerry. Because you already had a label that this color here, this person here is Jerry. This person here is Jerry. And any person that is like this is Tom. By the time you throw it into your model and you look at everything, then it's going to say, oh, this is Jerry, and this person that look like this is Tom. So this is how supervised learning works. So let's look at an example of supervised learning. So let's look at an example of supervised learning. So supervised learning is when you have your dependent variables and we have our independent variables. So let me stop sharing my, okay. I need to just end show, then I show you an example. Okay. So let's look at this. I don't know, I think you can see my screen. So we said this is a real estate. This is a real estate organization. And we have our variables. We have the average area income, probably the area that they're staying, the income they make averagely. We have, excuse me, keep this notification. Sorry for that. Then we have this average area house age, average area number of room, average area number of bedroom, area population, we have the price, and we have the address also too. So this is like a real estate organization, and they have this data available to us as a data scientist. And I said, oh, you know what? We just discovered a new environment. Okay, this environment, the average income they make is this. The average area house age is this. The average area number of room is this. And the average area number of bedroom is this. And we have the average area of population to be this also too. And the address is basically in this particular area. So can you tell us what is going to be the price? So we're saying, can you tell us what is going to be the what? The price of that particular house rent? So, you know, as a human being, you have this mere guess that, oh, the price could be maybe this particular amount. But as a data scientist, we are not in that area to make guess. We use the data we have to build the models. Then can I say from this, I think the price is going to be this model. From this model I built, I'm able to realize that the price of that particular house is this. So what we are trying to do is that we are trying to build models. That's what we are basically trying to do as a data scientist. We are trying to build a what? A model. So this model that we build is what we now use to determine the price. So like I mentioned, this area of income, house age, number of rooms, number of bedrooms, area of population, address, these are going to be our independent variables. Why price is our dependent what? Variables. So why price is going to be our dependent variables. So what do we mean by this? Is that price is what that is depending on the area of income, the house age, the number of room, the number of bedroom, the area of population, and the address of that particular area. It's going to determine the price. So it's going to determine the price. So these kind of problems, we have a label output, and our label output is price. Because when you have price attached to different data we have here, this is a data, this row is a data, this row is also another data. Because we already have price attached to this data we have here. Then we are going to be able to predict the price. So our price is going to be our independent variables, while other factors you are seeing, other variables you have here, is going to be our what? Dependent what? Independent variables. While our price is going to be our what? Dependent what? Variables. So this is an example of what? Supervised learning. This is an example of supervised. Don't forget in supervised learning, you have a label output. Our label output is our dependent variable, which is price here. And our independent variables are other variables you have here except price. So we have an algorithm that I'm able to solve this problem for us. So at Amdor Analytics is we teaching you those algorithms that is going to enable you to solve these particular problems. So don't forget, I said we have three basic problems we solve being a data scientist. We have the supervised learning, unsupervised learning, and we have the what? Reinforcement learning. So let me proceed to share my screen to the other problem we also have. Yes. So don't let us forget to fill in our attendance. So we have another problem called the what? Unsupervised learning. So we have another problem called the unsupervised what? Learning. So we said our unsupervised learning involves training by using unlabeled data. Can you see now? I'm following the guidance. Okay. I'm following the guidance on labeled data and allowing the model to add on that information without what? Guidance. Imagine when you learn all by yourself. So when you learn all by yourself, you feel like, oh, I get this thing, I know this thing. So think of unsupervised learning as a smart kid that learn without any guidance. Why? Supervised is when you have someone that teach you, put you through while you are learning. We said in this type of machine learning problem, the model is not filled with labeled data, as in the model has no clue that this image is Tom and this is Jerry. You figure out patterns and difference between Tom and Jerry on his own by taking in tons of what? Data. So let's look at our graph. Let's look at our graph. So we have unlabeled data. See, yeah, we don't know, maybe this is Tom or this is Jerry or anything. So by the time you throw this data into your model that is already built, then you can ask, oh, these people, they look alike. They are one family. You cluster them together. You say, oh, these guys look alike. They are also one family. Then it's going to cluster them together also too. So this type of problem is what we call the unsupervised learning. But when you look at here in supervised learning, you already labeled. So this is Tom, this is Jerry. By the time you see them, oh, this is Tom already now. So you just say, oh, this class is Tom. Look at this class. Oh, this class is Jerry. Oh, but in unsupervised, there is no any form of guidance. The machine learn all by himself. So the machine learn all by himself. So let's look at an example of that. So this is basically called clusters. Clustering are unsupervised what? Learning. We have clustering to be unsupervised what? Learning. So our clustering are what we know to be what? Unsupervised learning. So let's look at an example. So we have these customers that come to our supermarket. We have meal, the age, the annual income, the spending score also, we have all of this. But you don't know if it's an high purchasing customer or low purchasing customer or just a neutral person. So you want to know if it's an high purchasing customer or low purchasing customers. So what we're saying in unsupervised learning is that we don't have a dependent variables. We don't have a dependent what? Variables in unsupervised what? Learning. So we have to carry out that dependent variables. That's what we are trying to do in unsupervised learning. We're trying to what? Build a dependent variable. So by the time you build a model and you throw this person, the model will say that, oh, this guy is an high purchasing customer. Oh, this guy is a low purchasing customer. That's what we are trying to do. Cluster. We're just trying to build cluster with our what? Unsupervised what? Learning. So we're trying to build cluster with our unsupervised learning. So let's go back to our. So let's go back to. So question is coming. and you have opportunity to ask your own question also. So we have another problem called the reinforcement learning. So we have another problem called the reinforcement learning. So reinforcement learning is a part of machine learning where an agent is put in an environment and it learns to behave in this environment by performing certain action and observing the reward which you get from those actions. This type of this type of machine learning is comparatively different. I want you to imagine when they just drop you in an island that you've never been before. So I hope you understand what an island means. So imagine you are being dropped in an island. So how will you feel? How will you feel? What is going to be your experience when you are being dropped in an island? Yes. I think I have people that have joined us more. We have Mama, Elizabeth, you are welcome on board. We have Shidima also too. So welcome on board. And we have Sunday Unduka. So okay, I think I'll just ask someone this question. So I'm just going to ask Olatunji, can you help us out with this? Probably when you're just trying to do an experiment right now, I just take it through to a jet. I'll just be like, oh, you know what? I'm trying to take this experiment. I'll just drop you in an island using a parachute. How will you feel? What will you do? What will you do? Can you help us out? Olatunji, can you hear me?
Yeah, I can hear you. I can hear you. Please, can you repeat the question once again?
So I
Sorry.
said, imagine we just drop you at an island that you've never been before. How will you cope?
So I would try to actually understand my environment first before I can actually act on anything. But everything would look strange.
Oh,
That's it.
yeah. So thank you so much. You really answered the questions. Thank you so much for that. So reinforcement learning, we have this thing around us, but you may just not know that you have it around us. A good example is your Siri. Siri is an example of a reinforcement learning problem that has been solved. So you just say, Siri, call this person for me. Sometimes when you say, Siri, call Lekon, you can go and call Tunde. Say, guy, you are not serious. I say, she call Lekon. They say, oh, you mean Lekon? So you wash your hand as you move from one place to another. So, oh, this guy needed me to call Lekon. So next time when you say, Siri, call Lekon, immediately you just pick up it. You just call Lekon. So Siri is an example of reinforcement learning. So these are agents that we put in a particular environment that need to learn on it. So imagine we have different voice. So, during the testing phase of our project, like maybe you want to dispose want to roll out the new iPhone that we've developed outside there. And it's a white man that's testing it. So Siri call it, oh. So he get the terms and everything and is able to understand. By the time he comes to Nigeria, he says, Siri call it, and I can't recognize this voice. I just went to pick someone else. So as time goes on, Siri begin to learn. You begin to learn your voice. You begin to learn how you move around your phone, time people you call, suggest to you things you want to do. These are reinforcement learning. And we put you through this kind of learning also at Amdor Analytics. So our data science curriculum is being designed to solve this kind of problem also too. So just like Lekon said, Olatunji said, is going to learn from the environment first. So he's going to learn from the environment first. So we said at first, you gotta be sometimes you just be afraid. Of course, initially you will be, but as time passes by, you will learn how to live on the island. You explore the environment, just like understand the climate condition, the type of food that grow there, the danger of the island, etc. This is how exactly reinforcement learning works. You develop an agent, be stuck. So just as if you're an agent that has been stuck in that particular environment, then you must learn by observing and performing action that results in what? Reward. So by the time you say, oh, I do this, then I don't lose. I do this, then there's no any danger. I do this, there's no any danger. So these are things we do. So we say reinforcement learning is mainly used in advanced machine learning area. So we solve this kind of problem also with our data analysis, data science course curriculum that is being developed also too. So this is just a graph showing us the kind of problem. So I think we look at this type of machine learning problem. We have the supervised learning, unsupervised learning, and we have the reinforcement learning. And in our supervised learning, we divided it into two parts. We have the regression problem, we have the classification problems in our supervised learning. So what we mean by regression problem? So we say both of them are regression as supervised learning. So in a regression problem, the output is continuous quantity, while in a classification problem, the output is a category quantity. So the output in a classification problem is categorical quantity. What we mean by that? And let's look at that. Let's look at that. So we want to look at that by looking at this. So this is numbers. This is basically numbers. So the price, this is an example of supervised learning. Predicting house price, an example of supervised learning. Predicting of dollar rises, dollar falls is an example of supervised learning. Predicting of price of sugar, price of rice is an example of supervised learning. So predictions like that, example of supervised learning. And this is a regression problem. This is basically a regression problem. And we have that of, in supervised learning, we have that of what classification problem also too. So this is like an example now. We want to predict if a customer is going to leave your company or is still going to be in your company, like churn rate. So probably if your customer is going to be in your company. So we have this we have here our independent variables. So these are independent variables. The fact you have here are independent variables. And we have existed to be our dependent variable. You can see you have just 1, 0, 1, 0, 1. So these are categorical. You say 1 can be yes and 0 can be no. Yes is living, no is not living. So these are examples of what classification problems. So don't just forget, we have supervised learning, unsupervised learning, we have reinforcement learning. Supervised learning is actually divided into two parts. We have the regression problem and we have the classification problem. So this one example here is an example of unsupervised learning, that is clustering. You want to cluster your customers to high purchasing, low purchasing. These are example of what unsupervised learning. So in tomorrow's class, we are going to be working on a project that has to do with what classification problem. So you want to predict if a particular customer is going to leave a particular complaint or not. These are projects we'll be looking at in our tomorrow's class. So you can see how this particular algorithm works, how you can build this model. So we'll look at that in our tomorrow's class. So let's proceed. So we said our classification, we have unsupervised learning, and we have assigning data into cluster. Main aim is to group similar items together. So main aim of clustering is to just group similar items together. So that's one of the main aim. What main aim of classification, which is supervised learning, is to compute the category of the data, while the main aim of regression is to predict or forecast. So that is a major goal. So we have algorithms. So we have these algorithms that we basically make use of. So we have this algorithm that we basically make use of. So these are the algorithms that we make use of in classification and in regression and in clustering. So in classification, we make use of logistic, make use of Bayes-based, we use of KNN, decision tree, support vector machine, random forest. While in regression, we make use of linear regression, we make use of decision tree, support vector machine, lasso regression, ridge regression. So these algorithms are what we basically make use of in solving both classification and regression problem. And in unsupervised learning, we make use of these algorithms. So someone said at the beginning that is applying scientific method to solve problems. So these algorithms are scientific method in using solving what problem. So this algorithm are scientific method in using solving what problem. So we have our reinforcement learning also too. So we have our reinforcement learning also too. So we have Markov decision process, Q learning, we have the R learning, we have DD learning also too. These are what we use in solving problems also too for reinforcement learning. And the one beautiful part is that we solve all of these problems making use of all these algorithms, and we train you how to make use of these algorithms at Amdor Analytics. Are we together? We have the types of what? Machine learning problem, just like I showed you earlier on. So we have these activities. So can you please tell me what type of problem is this? Let's make use of the chat box. So what type of problem is this? So we have this. What type of problem is this? Let's make use of our chat box. Is it regression? Is it classification? Or is it unsupervised? Yes. Let's make use of the chat box. What type of problem is this? No one is wrong. Just try. Is it supervised learning? Yes, you're right. That is supervised learning. But I need you to now tell me if it's classification or regression. Do you think this is a classification or regression? Classification, amazing. That's correct. That's very, very correct. That is supervised learning and is a classification what problem. So that shows that I did very well in today's class. So let's look at the other one. So to study house sales data sets and build a machine learning model that predict the house pricing index is what type of problem? Is what type of problem? Is it regression or classification problem? That is a regression problem. That's amazing. That's correct. That's correct. So we said to cluster a set of movies as either good or average based on their social media outreach is what type of problem? Okay, someone is trying to mix it up here. Someone said unsupervised classification. So do you want to tell us, is it that it's unsupervised or is it classification or is both problem? So when we look at what clustering, so we are clustering set of moving as good or average. So we are clustering set of moving as good or average, good or average. What type of problem is that? Clustering, clustering. When you are trying to group cluster, maybe these people are rich people, these are poor people, these are average people. You understand? So it's what type of problem? Is what type of problem? Yes. Someone said, so is what type of problem? Unsupervised. Yes, you're correct. That is unsupervised problem. So that is an unsupervised what? Problem. So that we have that to be an unsupervised what? Problem. So that's correct. So that is correct. So you answered all the three questions correctly. So you answered all the three questions correctly. So thank you. We are actually done in today's class. In recap, in today's we look at what data is. So data are measures or record that you have in place. And we look at science. Science is the application of scientific methods in solving problem using what? Data. Basic problem we have are in three parts. We have the supervised learning problem, we have unsupervised learning problem, and we have the reinforcement learning what? Problem. So we see that our supervised learning problem can be either regression or what? Can either be classification also. Two, can either be of these two parts. a problem can either be of these two parts. So I would say clustering has to do with unsupervised learning. Reinforcement learning is when you place an agent in an unknown environment and you need to learn within that particular environment. So we have algorithm that we basically use in solving all of these problems, but we'll be looking at one particular problem in our tomorrow's class, which is the what? The classification problem. So we're building a classification model in our tomorrow's class to predict if a particular customer is going to stay within a particular company or not. So these are what we'll be doing in our tomorrow's class. So we've come to the end of today's class in case you have any question. So you can ask us, can ask me your question, or let me just say you can ask us your question. So yes, can ask us a question. So at Amdor Analytics, we have this curriculum that is being designed for every one of us. Even though you are a newbie, you have knowledge about anything. So we take you from that particular unknown knowledge to become an expertise in this field called data science. It's a very, very interesting field, fascinating one. And you can see we are solving problems, not that we are just there. We're solving problems. And that's one thing that's very, very excited about our field. We solve problems. So we solve problems. So I will just open the floor right now. If you have questions, you can just signify first. You can just raise up your hand, then I can call you, and then you can ask your question. Probably about our program, how we structured our payment structure. Probably you need question about the organization. So you can just ask a question at this moment. And please don't let us forget to fill our attendance. Don't let us forget to fill our attendance. Then we can forward the recording to you. So don't let us fill our attendance so I can forward the record to you immediately after the class. Yes, let's ask question. Let's ask question. If you don't ask question, I will ask question. If you don't ask question, I'm going to ask question. So let's ask
Yeah, good
question.
evening.
Yes.
Good evening. Yeah, this is actually my first time here. I was going through something on internet and stumbled across your website. So this is my first time. I just want to know what's the uh the program duration like. I saw 5 months while filling the form, and
Okay.
I
The
want to just
program
have a detailed explanation of the program, when it runs, the timing, because my schedule is totally different. I don't know if I can fit into the schedule. So before I start up with the program, I need to know how the schedule is.
Okay. So the program duration is actually 4 months, and our class hold weekend online. So it's an online class for now. We're working in our physical space. So it's an online class for now. It's all weekend, and it's all on Saturday and on Sunday. So on Saturday, 5 p.m. to 8 p.m. Nigeria's time, and on Sunday also to 5 p.m. to 8 p.m. Nigeria's time. So it's 4 month program. I hope I'm able to answer that question you asked correctly.
Okay, yeah, you've answered the question, but I want to know, is there an opportunity for a private lesson? Sorry, it's out of your course this evening, if I may say. If there is there an opportunity for private lessons, because my
Sure.
timing is totally different.
We
Yeah.
have opportunity for such. We are.
Oh, okay. So should I raise up the question in the WhatsApp platform, or do I
Definitely,
have a number I can communicate with?
you can raise that question also too on the WhatsApp platform. We have opportunity for private
Oh,
learning. You understand people
okay.
learn privately also too.
Okay. Thank you very much.
Yes. Okay, it's from Sunday to yeah, a minute. Let me go up. Wait. We from science field, we like to have a science mix explanation because some of us are into core science field. So sorry, do you want to explain that very well? I'm not able to get that question rightly. Do you want to meet yourself and tell us what you mean by that Sunday, so I can be on the same page with you? Yeah, Sunday Dogo, can you please unmute yourself? Okay. Yeah. So do you have anyone that asks question also too? So do we have anyone having question also too? Please ask, let's ask question. Let's ask question. Probably you want to be sure of, we are not certain sure of a particular information, you need some particular information, or probably what I explained in today's class. Then you can ask your question, please. This is an opportunity for us to ask our question. And you can use it, drop the chat box to ask a question. And I think the WhatsApp platform is also an avenue for you to ask a question. So Sunday Dogo, I'm not able to articulate your question very well. That's why I said you should unmute yourself and just ask your question so that we can be on the same page. Thank you.
Yeah, thank you very much.
Yes.
My question is this. Like myself, I'm core into science. So most of my analysis deal with science data. Maybe for example, like collecting soil sample data. Then most of the class now based on social sciences, maybe selling, buying, humans, population. But we know that maybe we collect tree samples, we collect leaf samples, we collect soil samples, or we collect water samples. And then we want to run all these things into machine learning, maybe using the regression, the prediction model, the classification. So now how can we be able to now import this into sciences? I think I will need more clarification on that and more class to be more science oriented to people like us. I think that is what I just want to ask.
Okay. Thank you so much. Thank you.
Thank you very much.
Yeah, I understand your question, and is most of the similar question I asked, my student actually asked. So based on that particular question you actually asked, so someone is okay, just a minute, Ibrahim, I'll get you. So based on what you said, like you do analysis on soil science, water, all this kind of analysis. These are things we also push you through. All these analysis, and most of the analysis you want to be doing are your t-test, hypothesis testing, and ANOVA. All of these things are things you want to be doing while you are doing your testing. These are things we put you through in this class also too. So put you through how you can do all of these tests, because you coming to this class, you are going to be having knowledge in data analysis and machine learning. So we have an aspect in our class that deals with statistics. So how you can actually apply all of these things in your, how you can actually integrate them in your core science field is not something actually difficult, because we walk you through how you can actually do them. So, and our problem we are basically solving is not just basically going to be on social problem, no, just general problem, scientific problem, and what we also solve also too. Not just only social problem. Very, very easy to integrate all of these things. In case you have some group of soil and you have the figures being clustered together, so you can use your clustering algorithm to group them. Okay, this is a loamy soil, this is a clay soil. Don't mind this, and this is a sandy soil. I don't think all those kind of stuff actually exist. So, but I think so. So those things when we are young, they say we have loamy, clay, and sandy soil. But I think you guys have.
You are still right. You are still right.
Is that what? I think it's different right now. So
no, you are right. You are right.
oh,
No, you are right.
so these are things we can use clustering to do. So you can have some kind of figures that you have together. So clustering could actually help you out in grouping them. So it's not a waste of knowledge. But if you have knowledge on this thing, I'm trying to assure you that I'm going to assure you that you had advantage over your colleagues and the peer you're actually working with. Yes, I hope I
Thank
was
you.
able to do justice to that
Thank you
question.
very much. Thank you very much. Yeah, thank
Yes.
you.
Okay. Okay, so Uraola, so you can just unmute yourself and ask your question. Thank you.
Thank you very much, sir. My own question is that, is there any difference between data analysts and data science? I mean, in terms of tech skills I mean the tech skills that they are there. You know that in data, some people say in data analytics, there's just a slight change for data science. I mean, for data analyst, you just be analyzing the data, and for data science, that one will involve in machine learning and other things like that. So I want to know about more. I want to learn about that, sir. So
Okay.
I don't know whether you can enlighten me more about it.
Okay, that's quite straightforward. I'm going to put you through that. So there's a difference between data
Okay.
science and data analyst. So data science is the father to data analyst. So so as I'm a data scientist, so I have data analyst people that actually work. Excuse me. That actually work under me. So data analyst people are just those people that actually do the data collection, they do the data cleaning, and they send the data to me that, oh, you know what? We actually identified this problem and we've collected the data, we've cleaned the data, and we've made data ready for you. So once they send it to me, then what I want to do is to build model on that particular data. So we data scientists build models. So we can also do the data cleaning, we can also do the data collection also too, but our basic goal is to build the models. So that's one thing that actually differentiates us between data science and data analysis people. So data analysis people do the exploratory data analysis, data collection, and data cleaning. While we can actually do the data collection, exploratory data analysis, and data cleaning, and also to we basically build our model. But one thing that actually differentiates us from a data science and data analytics people is that the data scientists are people that actually build model because you have knowledge about this algorithm of under supervised learning, unsupervised learning, and reinforcement learning. So that's one of the difference between. So data science is an advanced field of data analysis. I hope I was able to answer that question.
Yes, sir. Thank you very much. I really appreciate. Yes, sir.
You're most welcome. Yes, okay. Do we have anyone with question, please? Do you have anyone with question? Any question, please? Do we have any question? So I will advise you all to join tomorrow's class because we're having a practical section. I'll look at the problem, like I said, I'll try to see, I'll work on a particular problem I'll bring in a problem tomorrow for us to solve. Well, I can assure it's going to be a supervised learning problem. So we're going to solve that in tomorrow's class together. You see how very interesting it's going to be. Look at the problem statement, the data associated with the problem, and we develop um, our analysis and all of those model things there. So you see how it actually works then. When you join our full class, you see how you can learn all of these algorithms. So you see how you can learn all of these algorithms. So thank you so much for joining today's class. Please don't let us forget to fill our attendance. And I think our attendance is also on the WhatsApp platform. So you can use the WhatsApp platform to also fill your attendance also too, so that you can have access to today's recording for your revision purpose. So thank you all for joining today's class. I'll see you all in tomorrow's class. Thank you.
Imo Asekamona.